Hello everyone, welcome to another video on the rule of indices. Let's consider a mathematical expression of the form 8 square. So as you have noticed, I read this expression as 8 square, or this could be mentioned as 8 to the power 2, or I can say this is 8 raised to 2, which simply means 8 is multiplied by itself twice, where this 2 is called the index or power or exponent. Let's take another example, which is this form. So as I've mentioned here, this is read as 5 raised to 5 or 5 to the power 5, which simply means 5 is multiplied by itself 5 times. Similarly, in the first example, 8 is multiplied by itself twice, that is 64. One common mistake that a student might do is they would just do 8 multiplied by 2 and they write 16 as the answer. This is wrong. Similarly here, some of them might do this as 5 times 5, which is 25. This is something that needs to be corrected. So what do we do if we are to multiply two terms of this form? Now this is where the rule of indices comes in. Now without any rule, if we perform using the basic concept that I have just explained, this would be 7 cube is the first term, which could be written as 7 times 7 times 7, and followed by 7 square could be written as 7 times 7, and this in turn be written as 7 multiplied by itself 5 times, which is 7 to the power 5. Since it is a simple question, it was easy to answer, but what if the question is 7 raised to 80 times 7 raised to 50? In such cases, expanding each term out to its full form is a bit challenging, and for that we need to know certain rules of indices. So the first rule says x to the power m times x to the power n equals x to the power m plus n. So for multiplying two terms of this form, what do you have to do? You just have to add the indices together. This would be the answer. So let's see an example. 7 to the power 10 times 7 to the power 5. Since you have the multiplication operation here, you just have to add the indices together, which is 7 to the power 10 plus 5, 10 plus 5, which is 7 to the power 15. So similar way, let's see another type of operation, which is 7 to the power 5 over 7 to the power 2. Let's expand this out. That will be 7 times 7 times 7, which is 7 multiplied by itself 5 times divided by 7 times 7. So we could cancel out these, so the answer would be 7 cube. So this illustrates another rule of indices, which says x to the power m over x to the power n is equal to x to the power m minus n, which means if you want to divide one term of this form by another term of this form, then you subtract the second exponent from the first. So as you have seen in this example, let's try another one. In this case, 10 to the power 8 over 10 to the power 12. What we have to do? It's 10 to the power 8 minus 12, and the answer is 10 to the power negative 4. Now this 10 to the power negative 4 can further be simplified to 10 to the power 4 because of the rule which says x to the power negative m, let it be negative m or negative n, this could be written as 1 over x to the power m, which means, let's say for another example, 5 to the power negative 2, this could be written as 1 over 5 square. Or the other way, let's say 1 over 5 raised to 7 could also be written as 5 to the power negative 7. Now let's see another type of example. X cube the whole raised to 5. So when an expression of something like this is raised to a power, you could use the formula x to the power m the whole raised to n is equal to x to the power m times n. So all you have to do is just to multiply the exponents together. So that will be x to the power 3 times 5, which is x raised to 15. Now there is one more rule of index which says x to the power of 0 is equal to 1. Now this rule comes from the fact that dividing a number by itself results in 1. For example, x to the power 5 over x to the power 5. According to the rule that we have just studied, it is x to the power 5 minus 5, which is equal to x to the power 0, and based on this rule, applying this rule results in the answer 1. So to recap the rules that we have just studied, rule number 1, x to the power m times x to the power n equals x to the power m plus n. Second rule, x to the power m over x to the power n is equal to x to the power m minus n. Third rule, x to the power m the whole raised to n equals x to the power m times n. Fourth rule, x to the power negative m or negative n, this is 1 over x to the power m. And also we have studied that x to the power 0 is equal to 1. It should also be kept in mind that you cannot simplify operations that involve different base values. For example, you cannot use these rules to simplify the expression 5 to the power 5 times 7 to the power 5. These base values should always be the same. Hope this video was helpful for you, and thank you for watching.